Ready? All right, folks. Thanks so much for bearing with us. We hopefully reset the audio. If there's still some problems, send us a feature in the chat feature whether you're having still having problems. This next talk is on oaks and bioregional planning, and Tom Scott, who works for us in Cooperative Extension, he's housed at the UC Riverside campus, will be presenting this. Tom has worked in oak woodland conservation here for UC since 1986, mostly in Southern California, but also statewide and somewhat throughout the entire nation on developing conservation planning tools. So I'm going to turn it over to Tom, and he'll be with us for about 30 or so minutes. Once again, if you have any questions, record those on the chat feature.
I will apologize to everybody off the bat. I cannot see anything except my presentation, so I can't see your questions, and I'm going to have to rely on Mike and Rick to do that. I guess you guys can kind of understand who the victim of technology was this morning. In any case, I want to take you from what Greg has been talking about, which is he was actually a little bit more detailed in terms of oak woodland planning, and sort of extend that out to something that's a little more abstract, and to talk about one of the main ways that people are planning for oak resources right now, and that's through bioregional planning. So I think that one of the ideas that a person has to ask is, well, what is it, and sort of why is it being done? And so bioregional planning takes place when some preemptive regulation comes in and begins to control land use planning, which is traditionally under the control of local governments, sort of with the jurisdictional oversight of the state. So when the Endangered Species Act or Clean Water Act or some other law comes in, then there's a conflict between sort of federal mandates and local action. And that's one of the main reasons why we resolve these things with bioregional planning. Another thing that can happen is that you can have landowners who share a number of goals that they might want to achieve. The dairy farmers of Chino, other groups that basically join together because as a group they can handle an awful lot more sort of an economy of scale. They can take care of problems so the individual cost to each one of them is reduced. A third way is when we have resources that cross boundaries. I mean, as you all know as planners, that there are some biological resources that are just notorious for not following the boundaries of our cities, counties, and states. When things cross boundaries, it's often easier for two jurisdictions to work together to try to solve a problem, because without that, you can have sort of resources that basically sort of get ignored by both municipalities or counties, and then they become a really large exacerbated problem. So this is another reason we use bioregional planning to solve problems. I think that sort of also kind of defines where these things take place. That is, some natural boundaries such as watersheds. That's one of the main units that you see that are bioregional planning units. Another one is if you have something like, say, a landscape which has a lot of flatlands and then might have some kind of hills. So you might have a hills ordinance that is incorporating a lot of areas in a region which share the attributes of all being steep and being above ground or being above the farmlands below. Finally, the needs for specific management actions. The Endangered Species Act is basically an act of Congress and supersedes every other state and local law that we have. So in that sense, there may be mandates of the ESA, which then can drive an awful lot of processes, forcing people to say, well, the only way we can solve a problem is through something that happens on a regional basis. The people who promote these kind of activities, I think, are also sort of give us a real insight into how and why these things take place. A lot of these bioregional plans surprisingly come out of the land development community, and obviously in response to the Endangered Species Act, but often in response to any other number of regulations. Because what can happen is if you have a single landowner who's responsible for trying to say that they're going to cause the persistence of an endangered species, this can be too much on their single shoulders. But borne by a group of people, they can come up with plans for conservation easements or areas that might be set aside as a group which solve a problem. So the development community in many ways have moved for this. The other thing that the development communities are really looking for is certainty. And this point can't be understated, and I'll probably be saying this 3 or 4 times. I hope I don't get tired of it. But certainty in land development is critical, because if you're going to try to develop land, you need to know that from the moment you start the process until people are turning the keys in the houses, that there won't be something that stops and derails you. And a lot of the ways that our laws work provide an opportunity for things to step in and stop development, literally before people move into the houses they purchased. So because the ESA can stop land development at any point, that creates uncertainty, and uncertainty in markets is something that people don't like in general, but in housing it's particularly bad because there's an awful lot of upfront cost which then is recovered when the houses are purchased. And if you have banks in Zurich who are interested in knowing why you've got a 10-day delay on having your latest step in development, something like the ESA coming in and blocking you from doing something can be just an irretrievable problem which can cause you to go bankrupt. So certainty for land development is one of the reasons why we have bioregional planning. The other reason for bioregional planning is that conservation groups recognize that with dynamic resources that are spread over large areas, so that the piecemeal judgment of whether a piece of land should be saved or not often doesn't yield a composite which is sufficient for saving the resources you want to save. And I think that Greg covered this really well, so I won't say much about it except the idea of death by 1,000 cuts. You can have the best conservation planning in mind, and in the end, the resource is lost, or the last few landowners who try to develop their properties are stung because everything else has been developed, and they're the ones which are holding the resource. So resource planning on a larger level allows you to get sort of ahead of the bulldozers, so to speak, and allows you to sort of plan for prioritization of resources and how things might be managed. So, if we look at how these things have taken place, generally it's when they're mandated that they come into reality. And one of the things that I want to go on to talk about now is sort of a lot of the things generated from the Endangered Species Act. But we also have the opportunity to do this with those conservation plans, in the sense that we don't have a resource which is protected by the Endangered Species Act, but still we have the opportunity to take a resource and say, well, how would we as a community like to see this resource used? And within the bounds of land use planning and property rights, there are ways that you can actually sort of promote conservation on a broad scale, which then lowers the pain for any individual landowner and in theory allows groups to tax themselves and do other things to raise revenue to actually be able to set lands aside. So, why do we have so many of these bioregional plans in California? I always throw this slide in most of my talks. We live in a remarkable place. California's geology is like a calliope jumping up and down. And these mountains are very, very young in many cases, and the greatest scarp in North America can be found out on San Jacinto Mountain here east of us in Riverside. It's an 8,000-foot gain in elevation over a very short distance, about maybe 4 miles. What that means is that you can have birds like the vermilion flycatcher, which goes all the way down to the equator, and birds like the red-breasted nuthatch, which is found all the way up as far north as there are trees in the Yukon. And those birds can actually be within 8 miles of each other, 6 miles of each other. If you tried to replicate that in the Midwest, you'd have to basically go from Galveston up to Duluth, about 1,500 miles. So we compress things into a very complex landscape, and then we have sort of the boundary of Mediterranean and monsoonal ecosystems, so that rainfall can be in the winter in some areas in Southern California in particular, and in the summer only 20 miles away. So that dichotomy also produces a number of things, including a 6-month to 4-month drought that we experience over most of California over the summer. All of these things tend to cause a lot of complexity in our system. So, whereas we're not like tropical rainforests, in that we don't have hundreds and hundreds of tree species and thousands of insects and an incredible amount of biodiversity per unit area, the chances are good that if you go to any limited area within California, you're going to find a certain number of species which are only found in that area. In some cases, like I said, up to the species level, in other cases maybe subpopulations, but there's an awful lot of dividing and complexity, so that in any given spot, we have resources which are not going to be found anywhere else on Earth. And that's why we're considered one of the biodiversity hotspots, and that's also why we do a lot of this kind of planning. Whereas in some place like the Midwest, where you might not have anything but sort of a uniform eastern deciduous forest, we have remarkable changes in landscapes over very short distances, which makes planning really complex. Just to extend that to oaks, you can sort of see that we have at least 22 species and 28 varieties, and I'd opine that if you start to look within these guys, because they've been around for a long, long time and they've had a chance to differentiate, almost any place you go, you find unique genes that aren't found anyplace else. So we're dealing with a landscape which has a whole lot of intrinsic complexity. You can't just sort of say, well, as long as we're saving 20 acres of oaks over in this corner of the county, then we're okay because we're saving our oaks. Every place has something that somebody might be interested in fighting for. There's lots of different growth forms, and these oaks are distributed over a lot of areas, but the most important thing is, at least by taxon, at least 3/4 of our species of oaks that we have in California are found over some limited area that may increase their value to different groups. The other point about bioregional planning for oaks is that our oaks tend to be sort of scattered over large areas of landscape. So although oaks may only cover maybe 4 million acres in the state, if you look at how they're interdigitated with other habitats, you can find that there's literally most of the state has oak woodlands of some kind very close to whatever habitat might be under management. And this kind of gives you an example on a smaller scale of how this occurs, but you can have oaks on the far right-hand side. Those are oaks that are interspersed into coastal sage scrub, oaks in riparian, oaks in chaparral in the other two pictures. So most of the time our oak resource is diffuse, and it's spread through a whole lot of different kinds of complexity. And this is like Ginsu knives, and I apologize, but wait, there's more. I mean, a lot of cases we actually had stamp mills or firewood operations or other things which removed a lot of our oak woodlands. So in many cases, our oak woodlands are coming back, and so they're very dynamic. And this creates a whole other kind of complexity that, left over time, a lot of our oaks are going to continue to recover and take over parts of landscapes where they didn't occur before. And in fact, in the pollen records, you can actually see this increase that's occurred basically with the succession of agriculture and a lot of dry farming experiments. This just gives you a really close example of how this is a very dynamic system. It's really complex, and yet at the same time, if you look at the picture on the right, you can see a bunch of kind of like a land grant experiments or basically homesteading experiments with orchards and overuse of cattle and some dry farm for rye, and look at it basically 50 or 60 years later, and it's superficially completely similar to what we would call an oak woodland canopy with coastal sage scrub understory. So these systems have an opportunity to recover, and they are in fact in the process of recovering. But just about the time we're seeing global change, in which over the last two major fire events in San Diego County, we had over 50% of the distribution of Engelmann oaks burned. Engelmann oaks are not terribly good at responding to fire, so this creates a major challenge for them. So all of these reasons sort of bundled together gives us reason for thinking about all of our oak woodlands. Sorry, one more slide about all this. There are a whole lot of diseases and new things that are happening to our oaks, which further challenge the concept that we can go by parcel to try to protect the oak resource, that by getting larger groups of people together to consider this question, we may have a better chance of seeing our oak woodlands persist in the state. So the last little bit of complexity I want to put up here, because we have a problem in San Diego County right now with an immense number of trees dying as a result of a beetle infestation from southeastern Arizona. Now, what it's forced us to look at, though, is that there are oaks which have certain genes which adapt them to be in certain places. And if you're around for 6 million years, you have an opportunity to move a lot of genes to a lot of places and have a lot of selection forces take place. So we actually have a lot of hybrid oaks which are actually resistant to this particular beetle, they're looking at our oak woodlands, we can't just say, oh, we have a coast live oak woodland. What we have to start saying is we have a coast live oak woodland which is populated by Quercus agrifolia. We have a coast live oak woodland which is in a place that really is more suitable for the hybrids, or we have a coast live oak area that's actually for interior oaks rather than the hybrids or the coast live. So you can sort of imagine that there's a sea of genes, and every place where a particular group of genes can take off, that's the place where they're going to do the best. So again, oak woodlands don't become oak woodlands across a landscape. Like oak woodlands are basically, they can be subdivided on any level of complexity that we choose to, and if you have people who are have deep feelings about maintaining all of the oak resources, you start to see that people want to save everything. So how do we ensure that oaks basically fit into bioregional planning? And this is the other side of the equation. I spoke about certainty for developers. One of the interesting things that bioregional planning can do is it promotes persistence of a resource. But it's not necessarily in balance, because certainty for developers is often a permit, and once the keys are turning in the houses they've sold, their certainty is delivered and they can move on. Certainty in bioregional planning, on the other side, is much more promissory, and so the idea of persistence is what has been balanced against certainty. And this is not an even scale. I mean, if someone is going to end their process and leave the system, then they have far less at stake for persistence, whereas people who are anxious to have persistence will, in some cases, want to hold up the certainty for those people who might be walking out of the system. So this has been one of the big things that's happened in all bioregional planning, and occurs, I would say, in oaks as well, as we just witnessed in the LA County planning process. So, a couple of things to understand then, with all this complexity and with these two kinds of needs in bioregional planning, the two things that you have to remember is that there's an awful lot of unresolved values. That is, we all know what an oak woodland is in some cases, but if we all went out and tried to find it, we couldn't. We all have different values. People see different things. If someone is running cattle, they're going to look at an oak woodland and say, well, how many pounds per acre am I going to produce? Someone else can say, I love the trees, and these are the trees that are there. A developer might say, well, this is the ideal spot for the golf course. So you have a whole lot of unresolved values, which are not necessarily straightforward. And I'm not a postmodern relativist, so I'm relying on, I guess, two of the more famous ones, Ellis and Costello, and these guys basically had all these routines where they played on words, and I think it sort of fits as a compelling model for how we sometimes talk to each other. We start to go into these really complex planning exercises. The other part of the complexity that has to be dealt with is that you have a lot of different groups that approach this professionally. You have people who are professional wildlife biologists who might look at a landscape a certain way and divide it a certain way. You have engineers who look at basically at other things, perhaps hazards and risks. So you have to basically fold over a lot of disciplines if you're going to do something as large as a bioregional plan, because you're including a whole lot of different kinds of things that are going to take place, both sort of in a planning sense and stuff on the ground. And this leads to a surprising number of problems that people have had to deal with, where you wouldn't expect it, because everyone can be in agreement on saving the oak woodland, and the engineer's concept of saving an oak woodland is very different than the arborist concept of saving the oak woodland, which may be very different from the wildlife biologist concept of saving the oak woodland. So, to be a little more pragmatic, I apologize for being so abstract. There's a real sense, I think, of the need to do this with the rate of development that occurs and the amount of edge that we create. And the more edge we create in our landscapes, the more difficult it actually becomes to plan. Greg made a really good point of that. Also, we tend to have these sort of sweepstakes years of development where the development in California matches the gross national product of Pakistan. That's just the value of single-family detached housing. So we see a breakdown of an awful lot of plot-by-plot planning when you have so many houses glutting a planning system, and then basically all those planners get marooned when there's no planning to take place, when we have basically a collapse like we've had in the most recent years. That does not bode for a good model for doing any kind of unit-by-unit planning. And the other part about this that's important to recognize not necessarily adapted to deal with the wildland-urban interface. And so bioregional planning helped to meld local governments with federal agencies, because federal agencies for a long time were very reluctant to plan in wildlands because they didn't think that when houses were built next to their areas, there was still a resource that they should be managing. Whereas local governments would look at these areas and call them vacant and say, well, we shouldn't be managing these areas either. And as a result, these areas sort of fell through the cracks and received no development until the Endangered Species Act basically kicked in. And I'm short on time, so I'm going to sort of skip all the concept because it's really a reiteration of certainty and the promises we make.
Tom, we can go about 10 more minutes. We're okay if you want to slow down a little bit.
So if we look at multiple species plans, we can say, oh no, they're bad because there's an immediate demand for these things. We need authority and sovereignty, but we don't have clear lines of how they should occur. We don't know the environmental ethics, as I've talked about. We don't know what an oak woodland really is, what the value of these oak woodlands truly are. And we often don't even have a theoretical basis within ecology to deal with these concepts of these very complex threats that happen on a number of different levels. And Greg did a good job of identifying that. I won't go any further. On the other hand, I guess this is the relativism part of it. It's actually good because it gets these ideas, these bioregional plans get these ideas on the table. And as Greg said, he's in a lot of cases, you just listen to Greg really carefully, you don't even have to listen to me. The clearest distillation of democracy is when everybody gets together and muddles through on what are values in oak woodlands that we're really trying to preserve. And I think that's really important. I think that I said the ESA, but I think any kind of bioregional planning forces us to sort of say, well, what is natural and what can be left? What do we really want to save? And is it really the case that these lands, which are now going to be embedded in an urban landscape, can be left without some kind of management? So I think it's helped us to sort of start to look at a lot of the dogma and paradigms of conservation that worked when we were talking about large wild landscapes, but fall apart when we start talking about our bioregional planning areas and the urban fringe. So, we're lazy. So it's bad. These plans are bad because we let our democratic processes sort of run into sort of leveraging, and you see a lot of cases in bioregional planning, since they're so complex, everyone seeks their appropriate point of leverage, whether it's at a state level, in some cases through the State Board of Forestry, or whether they go through and try to go with some state laws or appeal to the federal laws. And in a lot of cases, it just makes the project more complex to go from a single project to bioregional. And a lot of times we let our philosophies go into autopilot. We don't really think about whether or not these things are actually capable of being maintained just as land we set aside. And we used to talk about the Hemazonia Zoo in San Diego, where a developer was forced to set aside 3 lots, that is 3 7th-acre lots, in a Hemazonia preserve, and they put a big fence around it, and it seemed to lose its value as the resource, and I think everybody lost, both the developer with the lots and the conservation groups that sought to save the resource. So I think what we have to be very cautious of when we go into these more complex planning arenas, as opposed to the ones that Greg was talking about, which are much more sort of focused and able to be dealt with on a pragmatic basis, we have to be careful about using our worldviews as knowledge, because both as professionals, as planners, and as scientists, you can't substitute discretion for logic. You can't sort of imagine that your moral intent is as good as actually having information. And in a complex system, having information can mean better things, but you have to make sure that you're collecting information on a broader basis. So, but on the other hand, these plans are actually good, because if we look at our environmental review process over the past 25 years, or now it's 35 years, we really haven't come up with a good system. It's hard to find an industry or a group of professionals where there's been an infusion of probably over $5 billion, where there isn't some kind of dramatic improvement in the kind of science and sort of things that they do. And because the ultimate judge of many environmental documents is the land developer himself, rather than a group of peers seen the kind of advancement that we should have liked to see with that much money being poured into environmental reviews. So what that means is when you start to get a bioregional review, many times you can step back and say, what kind of data do we need? So we do need to do something better than sort of the previous planning, and in that sense, they do help. So here's just a schematic. I know this is more of a point of social capital. Many times we see a process, and then we see how we fit in the process. I'm an ecologist, so this is how I define the process. You know, I'm going to be telling the economists and the people who are preserving things and the people who are trying to detect change exactly what's going on. You get a room full of people and you find the species specialists work one way, the GIS people work another, the politicians, the developers. Everyone comes with their own set of ways to solve the problem, and this is one of the things that you have to resolve over time. And again, I'm not a sociologist, but I do believe that the impact of these bioregional plans is that they're so big and they take so long that we actually can develop social capital between these groups, at least a common language, and that's led to an awful lot of resolution of problems, maybe even more than just the sense of it being a bioregional plan. You know, that said, there are some pitfalls. You have to be careful. Don't just use GIS. Don't become a polygonologist. This is the dumbbell model that I've created where we have two preserves and we demand that they're connected by a wildlife corridor. Unless we have a function for the wildlife corridor and it's actually meaningful, and that there are meaningful wildlife corridors, particularly some of the ones we've established in Southern California underneath our freeways. But a priori, we shouldn't be saying that we just need to have wildlife corridors everywhere, or we can draw blobs around things, and that's our best definition for what these resources actually are. The other thing is, no matter what we do, we still have a lot of unresolved social conflicts in terms of what is wildlife. In this particular case, that's one of my old field assistants feeding an endangered San Clemente kit fox and the San Clemente island fox. And you know, we don't really know how to treat wildlife. We don't really know in a lot of ways how we want to treat nature. And we really have to expose those things when we sit down and start talking about bioregional planning, because at some point we really do have to start to make decisions about what resources get minimized and what resources get prioritized. So that's one of the most important things that happens out of a bioregional plan. Finally, I am a resource manager. My hero is Gifford Pinchot, and I think that one of the best things about these bioregional plans is that we start to say, if we're going to set this stuff aside and deliver certainty to one group of people, and a bioregional plan which doesn't deliver persistence basically is just asking for trouble, primarily because the proponents will not go away and the remediation may be much more costly than a good plan and an endowment to actually carry that plan through time. So those are the sort of the high points of bioregional planning. And are we better off doing this sort of stuff? Well, for no other reason, we're starting to listen to each other in terms of defining our goals. And it's not a matter of singing Kumbaya around the sunset as much as saying, I'm a developer, but I understand conservationists' language and I understand what their needs are. And the same for the other side. The conservationist may not believe that the developer has a right to take this land and do with it as he pleases, but at the same time, they're willing to listen to what the developer's needs might actually be. So I think that we're better off with bioregional planning, and it's one of the things that we might want to start to consider with Oak Woodlands. So, and I'll end with this slide up just about, you know, don't go with truisms. You know, you have to use your head and be a critical thinker. That's my presentation.
Getting Doug's loaded up here. We did get several questions in on that presentation. So, Tom, what we'll do